Hi guys, let's do make the string great. So we're given a string S of lower and uppercase English letters, and a good string is a string which does not have two adjacent characters where basically S at a certain index I is a lowercase letter and S at I plus 1 is the same letter but in uppercase or vice versa. To make the string good, you can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string becomes good. And they want us to return the string after making it good. The answer is guaranteed to be unique under the given constraints. Notice that an empty string is also good. So if we look at the examples down here, we have example 1 where S equals this string, and we output LeetCode because in the first step we can delete this E here, like lowercase and uppercase that are next to each other, and the resulting string is LeetCode, which is what we return. And there's no more bad characters in the string. So in example 2, we return an empty string because in this input string we can delete BB here, which would give us this string, and then we can delete AA, which gives us this string, and then we delete CC, which gives us an empty string. Or we could do it in a different order and get the same result. In example 3, we return S because there's nothing to delete here, so we just return it directly. So here we're going to want to loop through our string and visit each character, and at each character we're going to want to have a stack where we check our stack for the same but like opposite letter, if that makes sense. So like if we have uppercase E, we want to check our stack for the lowercase e so that we can delete it. Or vice versa, right? So if we have lowercase e, we also want to check for uppercase e. But then since we're returning a string, it is easier to do this using a string builder. So we can make an empty string. And let's label our input string. Okay, so at index 0, we have an L, and then we check our string builder for an L, and we don't have that, so we're going to add an L. At index 1, we check our string builder for an uppercase E. We don't have that, so we add the lowercase e. At index 2, we have an uppercase e, so we're going to check our string builder for a lowercase e, and we do have that at the end, so we remove that, and then we keep going. So we have a lowercase e. Do we have an uppercase in our string builder? No, so we add this. We're at index 4. Do we have an uppercase E in our string builder? No, so we add this. At index 5, do we have an uppercase T in our string builder? No, we don't, so we add T. At index 6, we check for uppercase C. We don't have that, so we add C. At index 7, we check for an O. We don't have that, so we add O. At index 8, we check for a D. We don't have uppercase D, so we add D. And at index 9, we check for uppercase E, which we don't have, so we add an E. And then we're at the end of the string, and this is the resulting string builder, which is what we would return as a string. So let's start out by building our string builder. And then we are just going to loop through our string S. And then for each character, so I'm just going to say char C is s.char at I, just so we don't have to keep calling that. So the first thing is, or base case, I guess, if our string builder is empty, then we don't really need to check for any characters because there's no characters in the string builder. So then we can just directly add whatever character we're at. So if our string builder's length is 0, then we'll just add that directly. Okay, and then if it's not 0, then things get a little more complicated. So we need to check for whatever character we're at. Let's say we're at uppercase E. We need to check the last character in our string builder if it's a lowercase e. Or vice versa. So if we're at a lowercase e, we need to check our string builder if it's an uppercase e. And if it is, then we're going to want to delete that last character. And if it's not, then we just add whatever character we're at. So let's say our top character is the character at length -1. And then, okay, then now we need to do our check. So if character is lowercase top, and C is uppercase, or our character is uppercase top. So top is the last character of the string builder, and then C is the character that we're currently visiting in our string. So we just need to check if they're opposites, basically. And the opposite, and we need to check that they're equal to each other. So okay, if all of this is true, then we are going to delete the character. Okay, and then if they're not opposite of each other but the same character, then we're just going to add that character, and then we're going to return our string builder as a new string. So we're just going to do this for every single character in our I forgot an equal sign. Okay. I don't know what is up with me today, guys. I have so many typos. I think this part's just confusing to type out, but okay. So time complexity is O of n. N is number of characters in our string S. And that is because if we think about the algorithm, right, we are looping through the entire string, visiting every character once to be able to check if it is a matching but opposite character or not. Which we also that's what we do in this for loop here. And then our space complexity is also O of n because we need to add each character into a stack or string builder in this case. And we also make that a new string, which we return. So both of these are O of n. In worst case, if there are no, let me think. So worst case, yeah, if there's nothing to delete, so like in example 3 where we just have an S, then we add every character in our string, so n characters basically, into our string builder. So worst case is storing n characters. So that's it for this problem. Thank you guys for watching, and let me know what I should do next. Bye.